Reflective vests, commonly used on large and hazardous job sites, are often not permitted for electricians working on energized electrical panels. The primary reason for this restriction lies in the material composition of these vests, particularly the polyester fabric they are typically made from. Polyester, while durable and cost-effective, presents a significant electrical hazard. Firstly, polyester is a synthetic material derived from petroleum. Its molecular structure allows it to accumulate static electricity. This means that when an electrician wearing a polyester vest moves around or brushes against surfaces, the vest can build up a static charge. Secondly, this accumulated static electricity can pose a risk of electrical shock if the electrician comes into contact with an energized conductor. The static discharge can create a path for current to flow through the body, leading to injury or even death. Thirdly, in addition to the risk of static shock, polyester is also flammable. In the event of an arc flash, a polyester vest can ignite and melt onto the electrician's skin, causing severe burns. Arc flashes are explosive releases of energy that occur when a short circuit develops in electrical equipment. The temperatures generated by an arc flash can reach upwards of 35,000 degrees Fahrenheit, hot enough to instantly vaporize metal. The intense heat and pressure of an arc flash can cause serious injuries, including burns, blindness, and hearing loss. Fourthly, the presence of a polyester vest can exacerbate the severity of these injuries. When the vest ignites and melts, it can adhere to the skin, making it difficult to remove and prolonging the exposure to heat. Moreover, the melting polyester can release toxic fumes that can be inhaled, further complicating the situation. The National Electrical Code, or NEC, addresses the importance of appropriate clothing for electrical workers. While the NEC doesn't specifically ban polyester vests, it emphasizes the need for flame-resistant, or FR, clothing when working on or near energized equipment. Flame-resistant clothing is designed to resist ignition and self-extinguish, providing a crucial layer of protection in the event of an arc flash. Materials like treated cotton or synthetic blends with inherent flame resistance are commonly used in FR clothing. These materials are engineered to withstand high temperatures and minimize the risk of burns. Fifthly, OSHA, the Occupational Safety and Health Administration, also plays a role in regulating workplace safety. OSHA mandates that employers provide a safe working environment for their employees, which includes ensuring that workers have access to and use appropriate personal protective equipment, or PPE. PPE includes items such as hard hats, safety glasses, gloves, and flame-resistant clothing. When it comes to electrical work, OSHA requires that employees wear PPE that is appropriate for the specific hazards they may encounter. This means that if there is a risk of arc flash or electric shock, employees must wear flame-resistant clothing and other protective gear. Sixthly, in the context of energized electrical panels, the risks are particularly high. These panels contain live electrical components that can pose a significant hazard if not handled properly. Accidental contact with energized conductors can result in electric shock, arc flash, or even electrocution. Therefore, it is essential that electricians working on energized panels take all necessary precautions to protect themselves. This includes wearing appropriate PPE, following safe work practices, and energizing equipment whenever possible. Seventhly, many employers have specific policies regarding the use of reflective vests in electrical work. These policies often prohibit the use of polyester vests when working on energized equipment. Instead, employers may provide flame-resistant vests or require employees to wear flame-resistant clothing as an outer layer. The purpose of these policies is to minimize the risk of electrical shock and burns. Eighthly, it is important to note that not all reflective vests are made of polyester. Some vests are made of flame-resistant materials or blends that offer better protection against electrical hazards. However, it is crucial to carefully inspect the vest label to determine its composition before using it in an electrical environment. If the vest is made of polyester or any other flammable material, it should not be worn when working on energized equipment. Ninthly, when choosing reflective vests for electrical work, it is essential to prioritize safety over cost. Flame-resistant vests may be more expensive than polyester vests, but they offer a much higher level of protection. Investing in appropriate PPE is a crucial step in preventing workplace injuries and fatalities. 10thly, training is also a vital component of electrical safety. Electricians should receive thorough training on the hazards of working with electricity and the proper use of PPE. This training should cover topics such as arc flash awareness, electrical shock prevention, and the selection and maintenance of flame-resistant clothing. By providing adequate training, employers can ensure that their employees are equipped to work safely in electrical environments. In summary, reflective vests made of polyester fabric pose a safety hazard for electricians working on energized panels due to the fabric's potential to accumulate static electricity and its flammability. The NEC and OSHA emphasize the need for flame-resistant clothing when working on or near energized equipment. Employers should have policies in place to prohibit the use of polyester vests in electrical work and provide appropriate PPE to their employees. Training is also essential to ensure that electricians are aware of the hazards of working with electricity and the proper use of PPE. By taking these precautions, it is possible to significantly reduce the risk of electrical shock, arc flash, and other electrical injuries. Let's delve deeper into the properties of polyester that make it unsuitable for electrical work. Polyester is a polymer, a large molecule composed of repeating units. These units are linked together in long chains, giving polyester its strength and flexibility. However, the structure of polyester also makes it prone to accumulating static electricity. When two surfaces made of different materials rub together, electrons can be transferred from one surface to the other. This process is known as triboelectric charging. Polyester is a good triboelectric material, meaning that it readily gains or loses electrons when it comes into contact with other materials. When polyester gains electrons, it becomes negatively charged. When it loses electrons, it becomes positively charged. The buildup of static charge on polyester can be significant, especially in dry environments. Low humidity reduces the ability of static charges to dissipate, leading to a greater accumulation of charge. In addition to its tendency to accumulate static electricity, polyester is also flammable. When exposed to a high-temperature source, such as an arc flash, polyester will ignite and burn rapidly. The melting point of polyester is relatively low, around 250 degrees Celsius or 482 degrees Fahrenheit. This means that polyester will melt and drip when exposed to even moderate heat. The melting and dripping of polyester can cause severe burns if the material comes into contact with the skin. Moreover, the burning of polyester releases toxic fumes, including carbon monoxide and formaldehyde. These fumes can be harmful to inhale and can exacerbate the severity of burn injuries. Flame-resistant or FR clothing is designed to mitigate these hazards. FR clothing is made of materials that are inherently flame-resistant or have been treated with flame-retardant chemicals. These materials resist ignition and self-extinguish, providing a crucial layer of protection in the event of an arc flash. There are two main types of flame-resistant materials: inherently flame-resistant materials and treated flame-resistant materials. Inherently flame-resistant materials are made of fibers that are naturally resistant to burning. Examples of inherently flame-resistant materials include aramid fibers, such as Nomex and Kevlar, and multicrylic fibers. These materials have a chemical structure that makes them resistant to ignition and self-extinguishing. Treated flame-resistant materials are made of fabrics that have been treated with flame-retardant chemicals. These chemicals are applied to the fabric during the manufacturing process and provide a barrier against ignition. Examples of treated flame-resistant materials include treated cotton and treated nylon. The effectiveness of treated flame-resistant materials can decrease over time due to washing and wear. Therefore, it is important to follow the manufacturer's instructions for laundering and maintaining FR clothing. When selecting FR clothing for electrical work, it is important to consider the arc rating of the material. The arc rating is a measure of the material's ability to withstand an arc flash. The arc rating is expressed in calories per square centimeter, or cal/cm2. The higher the arc rating, the greater the level of protection. The NEC requires that electrical workers wear FR clothing with an arc rating that is appropriate for the potential hazards they may encounter. The specific arc rating requirements vary depending on the voltage and current levels of the electrical equipment being worked on. In addition to FR clothing, electrical workers should also wear other PPE such as hard hats, safety glasses, gloves, and insulated tools. Hard hats protect the head from impact and electrical shock. Safety glasses protect the eyes from flying debris and arc flash. Gloves protect the hands from electrical shock and burns. Insulated tools are designed to prevent electrical current from flowing through the body. By wearing appropriate PPE and following safe work practices, electrical workers can significantly reduce the risk of electrical injuries.